Okay, I don't. Oh, this camera's terrible. I don't even see if it focuses at all. I don't know. It's not like I can push it to make it focus. I don't know. So I don't think I explained the video quite well enough after I watched it. The Earth is not straight up and down. Like it's not on a straight axis. The Earth, oh, here I'll show with this. It's not on a straight axis. It's on a tilt of 23 degrees. Now, I believe this is due to the magnetic field of the sun. I believe that the south in the wintertime is being pulled towards the north, which I showed on the video. But I think maybe I didn't show that, I don't know if I can go back far enough, that I'm not turning this with my hand. I'm just holding it. As I go around, it's hard to watch the viewfinder and make sure my hand's in the video. So anyhow, as I go around, I'm not doing anything. It's the magnets that are doing it. As you can see, this would be summer. Now, as I was saying, I didn't explain it. The south pole of the North Pole here of the Earth, the top of the Earth, is pulling towards the South Pole of the Sun. That's what's going on. Oh. So that's what's going on. That's why the top of the Earth is pointed towards the Sun. And then when I rotate, as you can see, I'm not doing anything. The magnets are doing it themselves. As you can see, as I rotate around, now, if I get closer, the South Pole of the Earth is pulling towards the North Pole of the Sun, and the top of the Earth, which is north, is pointing away. So it's just like here. This is what I was showing right here. The north part of the sun, the south part of the Earth is being attracted to the north part of the sun. The north part of the sun is repelling the top part of the Earth, the northern hemisphere, and that's why we're getting winter. As it rotates, as I rotate around, and then the north part of the Earth, the northern hemisphere, is now attracted to the south, and that's summer. That's why when we're right here, I put a little dot. That's why when it's summertime, we're pointing towards the sun at this point, and that's why it's summer. Over here, that little dot way up here, we're pointing away from the sun. That's why it's winter. So I've showed with the magnets that as you rotate the magnets around the magnetic field of the sun, that this, which is just a representation of the Earth, it's just magnets, but we know that the Earth has a magnetic field, has a north and a south magnetic field. So I'm just using this as a prop to show how the fields interact, how the earth fields interact with the sun fields, and by using that analogy, I'm able to show that the North Hemisphere is closer to the sun's south pole in the summertime. And the Northern Hemisphere in the winter is pushed away from the sun because that's on the north face of the sun, and the bottom part of the earth, the south pole, is attracted and the north pole is repelled. So I hope this explanation of what I was trying to show on my first video, I hope this is a good explanation of what I was showing. That I was just holding the magnets. I wasn't, as you can see, the rope doesn't twist. There's no, of course I have magnets everywhere. There's magnets all over the place here because I was trying different things. I had to, everything's attached to it now. I had to extend it. I had to put a little ball on it to give it some weight, in order for it to work. Now, mind you, the Earth is a huge mass, and there's quite a bit of magnetic field. I'm not sure how much. You'll have to ask the scientists for that one. Anyhow, have a great day. Cheers.